Honors Algebra 2, Chapter 4 and 5. This is Part C. This is all about factoring. So we have 3 sections to cover. Before we start really getting into 4.3, I want to review what factoring is. So common factors is something with that. So we're looking at common factors of 12 and 36. We can actually list the factors of 12 and 36. So the factors of 12 are like 12 times 1, and then 6 times 2, and 4 times 3. So I kind of list them out. A lot of times I'll start with 1 actually. 1 times 36, and I'll work my way up. I know 2 goes into 36 because 36 is even. So I divide 36 by 2, I get 18. 3 goes into 36. I'm really using divisibility rules. If I add 3 plus 6, I get 9. 3 goes into 9, therefore 3 goes into 36. That's a divisibility rule for 3. And 3 goes into 36 12 times. 4, I know 4 goes into 36 9 times. And then 5 does not, but 6 does, 6 times 6. So the bottom here is all the factors of 36. The top is all the factors of 12. The common factors would be 12, 6, 4, 3, 2, and 1. These are all the common factors, are the ones that they both have as factors. What we want to find is the GCF, the greatest common factor. For this case would be 12. 12 is the biggest common factor. So here are the common factors. We want to find the GCF. 15 is the GCF, the greatest common factor of 15 and 30. That's what we're doing here. When we're looking at polynomials, we're really looking at each term, and we're looking for their common factors. We're looking for a GCF. So in both these terms, you look at the numbers 2 and 8. A GCF, or a common factor, there would be 2. And then the x squared and x, what's the biggest amount we can divide out from both of those is just x. And what we actually do is we divide each term by that value, 2x, that GCF. And whatever's left over here, we write within the parentheses. So if I actually reduce this first term, the 2's reduce, this x reduces with one of these x's, so I'm left with x plus, and here the x is reduced, 2 goes into 8 4 times, so we have x plus 4. It's the opposite of distributing, kind of, you can think of. Where if we distribute, we're multiplying. So if we distribute 2x through this parenthesis, we have to multiply. Well, factoring GCF, a common factor, is factoring it out, is pulling it out, dividing it out of the polynomial. And so we can look at the numbers separate than the variables, but you need to look at each term, really, is what we're looking at. So in these two terms, the GCF and the numbers, 2 is a common factor. 4 is not 2 and 7, but 2 is a GCF of those two terms, and then n is the most variables I can pull out of that. So we divide both those terms by 2n, I'll be left with 7n squared plus 10. And so this is factoring out a common factor. This is the first step we should always do with polynomials when factoring, is always look at all the terms and then pull out a common factor. So for this one, there's no variable that's a common factor for these, but the number is. There's no x's in all 3 terms, so you can't pull out x, but they all can be divided by 3, and so you pull out the 3. It makes our polynomial reduced or smaller, so we can solve it or evaluate or factor it easier. So for this one, a GCF, or a common factor of all terms, would be 5x. Pull that out, you're left with 5x squared plus 2x plus 3. And so this is a GCF, factoring out GCF. We can continue on here. These are a little more complicated. So for this one, pulling out a 6xy, I'll be left with 4x plus 1. Now we have 2 terms here. So when we factor out that, we should still have 2 terms within the parentheses. We gotta have the same amount. We don't lose the terms. We just reduce them a little bit. We pull out some of it. So 6xy divided by 6xy is still 1. So here, look at both terms. 3b squared, and we're left with b to the 3rd plus 4. And then continuing on, for here, 12, 18, and 30, I can pull out a 6, and then a y squared. I'm left with 2y squared plus 3y minus 5. So after you're done, you can double check to make sure everything has been factored, or a GCF has been pulled out, a common factor has been pulled out. So I'm going to leave this one right now, and this is going to be your first homework problem. So this one right here, first homework problem, I want you to pull out the common factors to rewrite that. So factoring, 4-3 is about factoring trinomials. And recall, we have to realize where these values come from. And to help us out, let's first do this example. We have to remember foiling. So foiling, we do the x times x to get x squared. And then we do the 3 times the 4 to get 12. Those are always the first two I do, the first and the last. And then this middle term, if you remember, it's OI. It's the 4x and the 3x here. So if I write that out, 4x plus 3x, that gives us the 7x. What we are doing is we are going to have this, and we're going to work backwards to those two polynomials or binomials multiplied together. And so we have to see where these different parts come from. Well, the x squared came from the x times x. The 12 came from a 3 times 4, two numbers that multiplied together to give us 12. The 7x came from the OI, which 4 times a 1x and 3 times a 1x. Since these are both 1, it makes the problem a whole lot easier, and that's what we're going to deal with today, is having those be 1. So in here, this x squared comes from the x and the x. The c is going to come from two numbers multiplied. So if I call this p and q, so it'll be p times q has to equal c. And then where does this bx come from? You need to multiply this q times the x, and then the p times the x, and then add them together. So it's almost like you're doing p plus q has to be the b value. Now I'm careful when I do this, because this only occurs when we have an a value here of 1, that these two would actually add together to be b. So it's kind of a special case. Tomorrow we're going to change that so it's not 1. It gets a little more complicated. And so factoring here in this example, we have the x plus blank and x plus blank. So the first part's already been written for us, x times x. So we're really looking for the two numbers that have to add together to be, or multiply together to be 8 and add together to be 6. And so 4 times 2 is 8 and 4 plus 2 is 6. So then I know when I break that up, it's x plus 4 times x plus 2. And if you go back and FOIL that together, you'll still get the x squared plus 6x plus 8. So this explains a little bit more, and this looks at signs. When we look at our signs, this number here at 32, where does it come from? We really need to be careful about our signs. So a positive. How do we get a positive through multiplication? It could be a positive times a positive, or a negative times a negative. So the two numbers that multiply with 32 can have to be the same sign. That's what it's saying, because b and c are positive. Both p and q must be positive for this problem. And it's because both these are positive. Where in this problem we have a positive 39 as our c value here, but because our middle term is negative, the only way to get that is if our two values that multiply with 39 have to both be negative. And so just looking at what the signs are, some logic helps me realize what the numbers have to be. So for this one, I know that they both have to be positive, and then for this one down here, the other one, I know that they actually have to both be negative, a minus and a minus. And so we need to have that forethought about the signs when we're factoring. If we're trying to factor them, the two numbers here that multiply with 32 add to be 12. And so you're going through the factors. If you need to write out the factors of 32, and so you can do like the 1 times 32, 2 times 16, 4 times 8, and you keep going, but you realize that these are the two right here that multiply or add to be 12. These two add to be 12, and so I know I have x plus 4 and x plus 8. Down here, 39, and then we have negative 16, so they have to be negative, so like a negative 1 times a negative 39. And then you can do a negative 3 times a negative 13, and then those two multiply to negative 16, and so I know I have it. X minus 3 and x minus 13. So let's continue a few more examples here. For these, we have to be careful of our signs. That's positive, so they have to be the same, but because that's negative, we know that they're both negative. So I know my framework. I'm drawing this. X times x gives me the x squared, and it's got to be a minus and a minus. They want to multiply to be 12, but add to be -8, so -6 and -2. For here, it's the first time we've seen a negative. The only way to get a negative here is when we make our binomials. We still have the x and the x to get x squared, but they have to be opposite. The only way to get -75 is if we multiply in two terms that are opposite values. So two numbers that multiply to be -75, but add to be 10. And again, you can go through, and this is interesting because when you're multiplying, we did like 1 times 75. They have to be opposite. And so you can make one negative, and I also can make a -1 and a positive 75. So 5 times 15, 3 times 25. If I can stop here, because I already see it, because these are really opposite. So when these are a negative c value, I'm really looking at the difference between these numbers. I know these two have a difference of 10. So I can have a -15, or I can make that positive and make the 5 negative. Now we have a positive 10 here. So when your c value is negative, you're really looking at the difference between these two numbers that add together to be the middle number. So the difference is the middle number, and they still multiply to be the last number. So we have to have a positive 15 and a -5. So if we're solving equations here, we're going to actually solve equations. So if we have m times n equals 0, the only way that's going to occur is if m or n has to be 0. The only way is when two things multiply to be 0 is if one of those two things is 0. So if we want to solve this equation, we want to factor it. Because if we can factor it, we now have two things that multiply together to be 0. So we know that one of those two things has to be 0. So we factor this. We still have the x and the x. And two numbers, we have the negative here, so they have to be opposite, negative, positive. So we have two numbers that multiply to be 24, but we don't want to add them. We want to have the difference to be 5. And so I'm thinking 12 and 2, that didn't work. 6 and 4, that didn't work. But 8 and 3, so a -8 and a positive 3. Now we have two factors, two binomials that multiply together to be equals to 0. So the only way that's going to be true is if one of these factors, if x minus 8 equals 0 or x plus 3 equals 0. One of these two things has to be true. So you solve both of them, and you find x equals 8 or x equals -3. So we're solving this equation. We are actually finding the x values that make this equation true. If we go back to our graphing, if we're graphing this, you recall that this is a quadratic, so it's a parabola. It's opening up, so it's going to have something like this. We want to know when this quadratic is equal to 0, which means we want to know when the y value is 0. So we're really finding these 2 points. We are really finding the intercepts, the x-intercepts. This would be -3 and +8, which if you also remember, we've graphed intercept form, and that's what this is actually in. It's kind of like intercept form if it equals y. You graph this quadratic. So we're finding these points here, which it can be called solutions, roots, zeros, x-intercepts, many different names that all mean the same. And so we're going to be talking about these for a couple of weeks, about finding these zeros. So we're going to do 2 more here, or I'm going to do one, I'm going to let you do the other. So we have this trinomial equal to 0. First thing we can do is factor it. We have a negative c value, which means that they have to be opposite signs. And then they want to multiply to be 64, but they want to have a difference that's 12. So 64, and if you want to write 1 times 64, sometimes it helps students to write out the different factors. 3 does not go. 4 times 16, and then, which I can stop here. I can keep going, but I can stop here because I'm looking for the difference. The difference has to be the -12. Now, which one has to be negative? I want more negatives. I want negatives when I'm left over, so I want more negatives in the problem. So I'm going to have a -16 and a +4. If you're not sure, you can go back through and FOIL to double check. But now it's been factored. The next step is to set each factor equal to 0. And then solve. So x here equals 16, or x here equals -4. So here's the other question I'm going to have you try doing. We're going to try solving this by factoring. So you want to factor it, and then you want to solve it. Call it good for the night. See you tomorrow.